Hi, seventh grade. I hope you're keeping cool in the heat. Gets pretty hot in the afternoons, huh? So we're going to use Venn diagrams to show relationships for events. Now look at this example. In certain situations, one event may occur at the same time as another event occurs. So let's look at the example of flipping a coin. Now, if we flip a coin, okay, um, let's say I have a big coin and I flip it, okay, um, and H is the event that it lands on heads, and T is the event that it lands on tails, okay. It's obvious that a coin cannot land on heads and on tails at the same time. When two events cannot happen at the same time, they are said to be mutually exclusive events. And we can use a Venn diagram to show mutually exclusive events. The Venn diagram below will show mutually exclusive events of getting a heads and getting a tails when you flip a coin. So look here. Here's event H of getting heads, and here's event T getting tails. Notice they're not overlapping each other. They're separated. Because the circles for event H and event T do not overlap, the events are mutually exclusive. Let's look at another situation. Let's look at the situation of rolling a number die. So a number die has 6 faces, right? And there are the numbers 1, 2, 3, 4, 5, and 6. Those are your choices. So let A1, A2, A3, A4, A5, and A6 be the events you get 1, 2, 3, 4, and 6 respectively. It's obvious that any two of these events cannot happen at the same time because there's only going to be one number that faces up when you roll a 6-sided die. And here's a Venn diagram that shows how these events are mutually exclusive. So we have A1, A2, A3. We have A1, A2, A3, A4, A5, and A6. And notice that they're not overlapping one another. Okay? And so these are called mutually exclusive events because this Venn diagram does not overlap one another. The circles do not. Now, think about these two events related to a 6-sided die. Let E be the event of rolling an even number, and F be the event of rolling a number greater than 3. So, your outcomes for E is 2, 4, and 6, and F is 4, 5, and 6. And the sample space is 1, 2, 3, 4, 5, and 6 for a 6-sided die. So look at the Venn diagram below. We're not only going to draw the Venn diagram, but we're going to draw the sample space around it. We show the sample space by drawing a rectangle around the Venn diagram. Now, circles E for event E and F overlap because look, 2, 4, and 6, 4, 5, and 6. What numbers do you see that they have in common? They have a 4 in common and a 6 in common. So event E and event F circle will overlap with 4 and a 6. And because they overlap, they are not mutually exclusive. Take a look at what it looks like. Okay? So look at this red circle, that's event E, and look at the blue circle, that's event F. So E has 2, 4, and 6. F also has 4, 5, and 6, but the overlap is 4 and 6 here. Okay? Notice that they labeled the name of the event outside of the circle near it, like so. Okay? And look at the sample space here. They put a rectangle and they drew a tiny S here in the corner. And you can draw the S anywhere, just next to the rectangle. And they wrote the other events, the other outcomes here that were not included in the sample space, okay, from event E and F. So then 1 and 3 were not included, so then they just wrote it here. You can write 1 and 3 anywhere, as long as it's inside the rectangle and not inside the circles. All right, so let's look at another example that shows mutually exclusive events. Now this means that there's no overlap between these events. So look at this example. There are 10 cards, each printed with a different whole number from 16 to 25. So I'm going to draw those 10 cards here, okay? A card is drawn at random from 10 cards. Let A be the event of getting a number that is a multiple of 3. So let's see, my outcomes for A, that's a multiple of 3, is 18, because 3 times 6 is 18, 21, because 3 times 7 is 21, and 24, because 3 times 8 is 24. Now let B be the event of getting a number that's a multiple of 5. So 20 is a multiple of 5 because 5 times 4 is 20, and also 25 is a multiple of 5 because 5 times 5 is 20. Okay? So question A says, list all the outcomes favorable to events A and B, and it's right here. Draw a Venn diagram for the sample space and the two events. So remember, the two events are my circles, okay? And my sample space is my rectangle around my circle. Place all the possible outcomes in the Venn diagram. Okay? So here's my A, and I have 18, 21, 24. And here's my B, 20 and 25. Okay? There's no overlap between the two, okay? Because they don't have any numbers in common. Okay? And my sample space here, they just listed the numbers that were not used in A that were not used in B. So 16, 17, 19, 22, and 23 were not used. So then they included that. Okay? And again, notice for the sample space, they drew it in a rectangle outside the two circles for events A and B, and then they also wrote an S to show you that it's labeled as the sample space. Now C. Question C says, are events A and B mutually exclusive? Yes, they are, because there's no overlap. So they are mutually exclusive. Okay? And now look at D. Find the probability of A and probability of B. So the probability A is the number of outcomes favorable to A divided by the total sample space, number of items in the sample space. Now there's 2, 4, 6, 8, 10 items in the sample space, so I put that in the denominator. How many outcomes are favorable to A, event A? 1, 2, 3. 3 is, so I'm going to put that in the numerator. So my probability of A is 3 out of 10. My probability of B, of event B, which is getting a number that's a multiple of 5. Again, my total sample space, total number of items is 10, so I put that in the denominator. My numerator is the total number of outcomes that are favorable to B, which is 2. So I put that in the numerator, so it's 2/10, okay? And then I can simplify that, and that'll become 1/5, or 1 out of 5. All right, I'm going to pause the video, try number 5, A, B, C, and D, and let's see what you get when you come back. All right, welcome back. So let's get number 5. Now we have, I'm going to just make my video screen a tad larger so you guys can see, okay? Okay, so for 5, okay, I've got my cards here that have the following numbers, okay, and there's 10 cards, right? Okay, with these following numbers, and W is the event of getting an odd number greater than 20. So my W is here. An odd number greater than 20 is 27, 35, 39, 45, according to my sample space. And my V is the event of getting a prime number. So remember, a prime number is a number that can only be divided by itself or 1. Okay, so it has to meet those two conditions. So 3 is a prime number, 11 is a prime number, 19 is a prime number. I almost put 39 as a prime number, but I realized, oh, 3 times 13 is 39. Okay, so I had to erase that after I did it. Okay, now Let's look at B. B says to draw a Venn diagram for the sample space and the two events. Okay, is there any overlap between event W and event V? Let's see. There's no 3, there's no 11, there's no 19. Nope, there's no overlap. Okay, and so these are mutually exclusive events. So that means my circles for my event W and my event V will not overlap. And I have to also draw my sample space, which is a rectangle around my two events. Okay, so it should look something like this. Okay, and so notice that W and V do not overlap, and then my sample space is my rectangle, and I just put an S here, okay, somewhere near my rectangle, okay, and I labeled my events W and V outside of my circles, okay, and I put the values, my outcomes inside my circles here, okay, and yeah, and then whatever I didn't use as my outcomes inside my circles or my events W and V, I put it in the rectangle somewhere. Okay, again, where you write it inside the rectangle doesn't matter as long as it's inside the rectangle but outside of the circles. Okay, all right. Now C says, are the events W and V mutually exclusive? The answer is yes, they are mutually exclusive because there's no overlap between event W and event V. All right, and now okay, here we're going to find P of W, the probability of W. So remember that there were 10 total outcomes in the sample space. So I'm going to put that in the denominator. Okay, what was how many items did I have that were favorable? How many outcomes did I have that were favorable to W? Okay, so let's count. So W is 1, 2, 3, 4. 1, 2, 3, 4. So there were 4 favorable outcomes for W. So I'm going to write that here. Okay, and 4 out of 10, you can write it also as another, simplify it by 2/5, or you can also write it as a percentage, which is 40%, or you can also write it as a decimal, which is 0.4. Okay, all right. Now let's look at probability of V. Okay, the probability of V, again, the total number of outcomes is 10, so I'm going to write that in the denominator. That's the sample size, right? And then, or yeah, sample space, I mean. And then outcomes favorable to W, let's count them. So that was the prime numbers. So it's 3, 11, 19. So that's 3 outcomes favorable to W. I'm going to write 3. So that's my fraction. My percent is 30%, or my decimal is 0.3. Okay, so these are 3 different ways to write the probability: as a fraction, as a percent, and as a decimal. Okay. I thought that kid was funny. All right. So let's keep going. Okay. Now let's use Venn diagrams to show non-mutually exclusive events. Non-mutually exclusive events means there's an overlap with the events. Let's look at this example. A name is randomly chosen from a list of names. We have Bill, Jesse, Ava, Chloe, Mary, Ruth, Kim, Henry, Elsa, and Sean. Oh, it's so funny that they have Jesse and Henry in here, huh? They're spelled differently for Henry, though. Now, we're going to let X be the event of choosing a name with 2 vowels, okay? So these names have 2 vowels in it. Remember, vowels are A, E, I, O, U. So here's 2 vowels, here's 2 vowels, here's 2 vowels, here's 2 vowels, and here's 2 vowels. So it's Jesse, Ava, Chloe, Elsa, and Sean. Are the outcomes for X. Now, Y's outcome is choosing a name made up of only 3 letters. So only 2 names have 3 letters, Ava and Kim. Okay, and so question A says, draw a Venn diagram for the sample space and the 2 events. Place all the possible outcomes in the Venn diagram. Now, do you see any common outcome for X and Y. Let's see, I see Ava twice, right? So that's the common outcome. So there is going to be an overlap in these events X and Y, okay? So it's going to look something like this, where Ava is the overlap between event X and event Y. Now Y has Kim and Ava, and X has Jesse, Chloe, Elsa, Sean, and Ava, where Ava is the overlap. And my sample space is my rectangle around my events, and we write the names that weren't used in the outcomes for X and or in the outcomes for Y here. So we just write it out here. Okay. Now, are the events X and Y mutually exclusive? Are they mutually exclusive? No, they're not, because there's overlap with Ava here. So they're not mutually exclusive. Okay. Now, we're going to find the probability of event X and probability of event Y. So probability of event X, remember there's 10 names in the sample space, so I'm going to put that in the denominator. Now, outcomes favorable to X are 1, 2, 3, 4, 5, so that goes in my numerator. I can simplify that, and that'll be 1/2 as my probability for the event X. What about probability for the event Y? Again, there's 10 items there's 10 outcomes, equally like the outcomes in the sample space, so I put that in the denominator. Now my numerator has my outcomes favorable to Y, which is 1, 2. So it's 2 in the numerator. And I can simplify that, and that'll become the fraction 1/5, or 1/5. All right, can you pause the video and try number 6, A, B, and C on your own? And when you're ready, let's check our answers together. Isn't that dog so cute? Okay, enjoy. All right, how's the problem? Are you guys starting to get it? I'm having fun with this chapter, just drawing the Venn diagrams in the sample space. I don't know about you. Well, let's look at number 6, okay? So I'm going to just make my video screen a tad larger so you guys can see it better. How do I make, maybe if I put it here, and then make it a bit larger. Yeah, I'll just make it, just put it here. Okay, so a letter is chosen at random from this word, Rhode Island, okay? Now, event C is the event of getting a consonant. A consonant is not a vowel. A vowel is A-E-I-O-U. So consonants are R, H, D, S, L, and D, okay? So I wrote it inside here. Those are the outcomes for my event C. Now, my event H, it says, it's the event of getting a letter after the letter H in the alphabet, okay? So R comes after H, no, yes. O comes after H, no, no. I comes after H, S comes after H, L comes after H, no. N comes after H, no, okay? So it's R-O-I-S-L-N, okay? So those are my outcomes for event H, okay? But now it says to draw a Venn diagram for the sample space in these two events. So let's see. Is there any overlap between these two events? Okay, so let's see. Oh, I see R. I don't see an O. I, no. Oh, I see an S. I see an L that overlaps. And I see an N that overlaps. So these overlap, okay? Now, for here, in the sample space, were there any letters that were not, that was not an outcome in event C, and that was not an outcome in event H? Let's see, R was, H, was it? Yep. O, was it? Yep. D, was it? Yep. E, was it? Oh, E wasn't here. Okay, so this wasn't an outcome in the sample, in event C and H. So I have to write that in the sample space in the rectangle. What about an I? Is there an I? Oh, there's an I. What about an S? There's an S. What about an L? There's an L. A? Oh, A isn't either. Okay, so I don't see an A here or here. What about an N? I see an N. What about a D? Oh, here's a D. Okay, so here you go. Okay, so this is our information. Okay, so the letters I underline for events C and H, that's the overlap. Okay, in the events. And in my sample space, I'm going inside the rectangle, but outside of the circles of event C and event H, I'm going to write E and A. Okay, so it should look something like this. Okay, all right. So notice I wrote my sample space here, E and A just here. I just wrote it somewhere inside the rectangle but outside of the circle. For my event C and H, my overlap was R, S, L, N. And I wrote the other letters in event C here and event H here. Okay. Now B says, are the events C and H mutually exclusive? No, they are not mutually exclusive because there's an overlap with the outcomes R, S, L, and N. Okay. Now, oops, you don't get that celebration yet. Okay. Let's look at C. C says find the probability of event C and the probability of event H. Okay. So let's see. Probability of event C. Okay. Well, first, what's the sample space? How many letters were there in the sample space? Okay. Let's look here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 letters in the sample space. Okay. So I'm going to have my 11 here. And how many outcomes did I have that were favorable to C? Okay, let's count it here. Okay, so favorable to C, 1, 2, 3, 4, 5, 6, 7. 7. Okay, so here's my probability, 7 out of 11. Okay, now the probability of event H is, so my total number of equally possible outcomes in my sample space was 11, so I'm going to write that in my denominator, and my numerator is my outcomes favorable to H. Let's count it. Okay, over here, let's look back here. So 1, 2, 3, 4, 5, 6. So there's 6. 6. Okay. All right. So now, looking at the probability of event C and probability of event H, which one is more likely to occur? It's actually probability of event C because 7 out of 11 is greater than 6 out of 11. Okay. All right. Way to go. All right, well, that's all for today. I'll see you tomorrow in Videoland. Bye.